Now that I've modified the TL21 device by adding a connector to it, I'll prepare this. Now I'm going to use 2 pair of shielded wire with a red and white in each one and a shield. I wanted to make sure that this clamping device actually seized the wire and held them. And I'm pulling as hard as I can. Proceed to solder these wires onto this connector. Taking 2 pieces of cable, each with 2 conductors and a shield, and I've fastened them to this connector. If you tear one of these apart, you'll find inside a little plastic thing. That should slide over the cables. Be secure to, just force fit over the wires there. Then take this the whole way off. And proceed to slide it over the cables. I'm going to hold this in my vise. I'm going to hold these cables in my hand. I want to try to keep them from interfering with my screwing on. I don't want to let these cables twist. So it's tight. And we can proceed now to put the clamp on. Here we go. I go to the other end of the cable. I'll strip it, separate the shields from the conductors, and then measure continuity and look for shorts. Between the ends and the surfaces, both sides, these terminals. First thing I'm going to do is put some series of heat shrink tube on here to pair these conductors. Now, these are polarized. Not so important for resistors and inductors, but for electrolytic capacitors, we want to obey this polarity, which makes this terminal both inside and out. Remember, it's double-sided. The positive terminal. These wires as of yet are unidentified. The next thing we want to do is identify the red and black leads. So this pair of wires we're going to label red. I'm going to do that by placing a little piece of heat shrink tubing over the wire. And so then I'll place a piece of black heat shrink tubing over the remaining pair of wires. Now I intend to use, for this first pair of cables, these little cheap connectors, which are color coded. However, if I was going to use something like this, where I would have to remove at least this, well, I'd have to remove both of these pieces of heat shrink, and I'd be left with a neutral color. So I'd have to identify positive and negative, or high and low, with some sort of color. Now the braid is going to end here. And so I put a little piece of heat shrink tubing here, both to act as a strain relief and to insulate the end of the braid. I've got my heat shrink tubing here. I've soldered one of each wires to one of these. One wire to one of them, one wire to the other. These two marked surfaces with the wire grippers, they'll face each other. We'll go like that. Now these little contacts will fit down between, on each side, the spring. So I'll insert them. The white one in there. Push it down forward. Get the red one over on this side. Okay. I need to push them forward enough that they line up with the front of the housing there. And that's it. We're done. Well, we're done with one side. Here's our completed modified TL21. We'll do a calibrate, that's 2-second hold. Wants me to verify the leads are open, and they are. Count down to 30. Okay, passes. Wants me to short the leads out. Now to do that, I'm going to clamp them on a piece of wire. The wire I'm going to use happens to be fastened into a resistor, but that doesn't enter into the equation. So there we are, as close as possible to a short. So it should read 0 ohms now, or 0 something. It's going through the search mode. It's an LCR, auto detect mode. This is a 0.005 ohm resistor. And there we go. 5 microns. This will be a 0.01 ohm resistor. And there is 0.01. So this machine is obviously capable of eliminating the resistance due to the wiring. Inductance and capacitance will be another matter, though. I have an unmodified TL21. I'm going to do a calibration again with the unmodified unit in. I'm going to short it to a single wire. I'm going to verify the short. Alright, so we've got it calibrated with this unmodified interface. I'm going to hook this nominal, well, I don't know what it is, inductor. That measures our unknown inductor as 104. 1.2 micro henries. We'll try a silver mica capacitor now. And I'm going to call that 810. And both of these measurements are at 1 kilohertz. We'll hook up our modified interface. Go through the calibration procedure again. Hook up our inductor. And now we read 1027.3 microhenry. Hook up our capacitor. 809.5. Let's go back to our original unit. Change the frequency to 100 kilohertz and calibrate it. There's our inductor. And this is at 100. Our capacitor. Change the interface. Still at 100. Our capacitor. Now let's go back to our original unmodified setup. Turn it on for the first time. Calibrate it. Open. Now, this should put us back to, well, I'll use the inductor first. This should put us back to 1041. Same exact setup here. 1 kilohertz, same capacitor. 1024 versus 1021. So, if we do the same test over twice, and we get a variation of 20, what's wrong with this? Nothing. Let's take a look at our standard capacitor, which is really just a silver mica. I picked a random out of the spare parts bin. Okay, here we are at 809.8. We should be at 810. And here's what we were with the modified leads. Here's where we were with the modified leads. So, the modified leads make no difference. I think this little modification works fine. And I'll proceed to make some more of these leads with different Kelvins on them, with different clips. I'll do a set with these clips. And I have accumulated somewhere here a pair of genuine alligator clips. They look like alligator clips. So I'll say goodbye, and if you've watched both videos, thank you.